Like I should have told my freshman what's going on.
Any other homework assignments? All right, are we ready to get started with week 13? Let's talk about week 12. Week 13, here we are. Here's your instructions. Week 13 assignments are due a week from today on December 5th. All right, here's an announcement. Week 14 assignments, I'm switching to never. Do never. Everybody hear that?
Can you make an extra credit?
No. I appreciate it when you show up.
Thank
you. Look.
I love
You love me?
I love to show up.
Oh, okay, So look what I had to do. I had to post another, this is the fourth new calculate your own grade spreadsheet because I had to change the percentages again because now we have one less homework assignment. So now we only have 10 homework assignments instead of 11. We had 12 to start with and now we're down to 10. But each one's worth 2% instead of 1.8181, whatever it was. So I had to switch them all to 2. So when you go back there, and if you notice, I moved all of the weights from column H over to G except for what hasn't been done yet. So let's look at what hasn't been done. All the weights have been moved over except for week 13 homework, which you have not handed in. Wait, where's week 12 homework you just handed in today, so that hasn't been graded. Week 13 homework, week 13 in class on Thursday. Week 14 homework's a 0 because it no longer exists. And then week 14 in class. Participation and your final exam. So we're at 68% finished, leaving 32% of your grade that's still out there for you to do what you want with. So what I haven't done yet is I haven't gone to Canvas and switched the weights there for the homework. So today, when I go to Canvas and switch it to 2% for every homework assignment, your grade's gonna jump up a little. Let me give you a heads up. That's an artificial jump up. You know, don't celebrate too bad. Because these, you know, doing these homework assignments, in-class assignments, are what's offsetting you accidentally possibly falling apart on one of the quizzes or the final exam. So this is kind of usually everybody's homework assignments are better than what they did on a quiz. So if I move all the homeworks up to 2%, you're gonna see your grade kind of give a jump up. So just realize that what's going on, why that's happening. I wanna talk about participation for a minute. Wait, yeah, I do wanna talk about participation. I just wanna give you a heads up. I forgot to switch it. I don't think there was 25 lectures, or was there?
24 maybe.
I think maybe it's 24 instead of 25, I can't remember. Let's just hypothetically, I'm just showing you how you can do this because we're getting so close to the final that a lot of you start to ask questions like, what do I need on the exam to get this grade or that grade? And this is what you're using this for. So when you get to the participation part now, I'm just gonna show you some hypothetical numbers that you could enter in maybe just to kind of estimate your grade. Let's pretend it's 25, maybe I'm gonna count it officially and switch it. We'll have probably a 5th spreadsheet posted later today if it ends up being 24. But let's say you showed up to all of them except for, let's say you were late 4 times. So every time you're late, that's a fourth of a day absent, so that'd be 1 day absent, so you would be at 24 out of 25 attended, right? 4 days late. Now, helping others. This is these two, speaking up and helping others, are the only place where I have to make a judgment. And so, you know, did I learn your name? You know, can I recognize you at this point in time? Did I see you get up and help others? I'm just gonna put an average there of, I don't know, 90. Because everybody's in the 80s and 90s. I know, I grade participation hard, don't I? Should I put a 91? You guys are freaking out with the looks on your faces. There. You feel better? Okay, what was that? I was helping others. Speaking up, same thing. I give like one person 100, and then like everyone's 99 on down to, You know, someone didn't hardly speak up that much and, you know, maybe they're like an 80. But, I mean, if somebody didn't show up hardly at all, like, I don't wanna pick on Rose here, but, you know, if you hire, like, you know, hardly show up at all, I don't think he could speak up much, so I don't even know if I could give him an 80, that'd be tough. You guys will have to tell me what to do. If he's hardly ever here, what grade should they get for speaking up?
85.
No, 85? Well, no, we're figuring out what grade below 80. 80 would be, okay, anyway, I'm going to 91. Emails. Look, all you gotta do is you go to your email and put McCarthy, it will bring up every email you sent to me and I've sent to you. Then you're looking for 2 on 2 different days where you didn't attach anything to it. That you were just sending me an email, maybe it said because I want participation, or maybe it said, maybe you had a legit question. Find 2 on 2 different days and you know this is done. And if you didn't do this, then you got what? You got another week to get them in, 2 different days. Don't attach anything. Just send it in, say I want participation. So I'm putting 2 there, it'd be crazy for you not to get it. Now, here we go, the course evaluation's opened up. And when you do the evaluation, you're gonna get to a page after you're done that shows each one that's completed. And it looks like this. Like that. See where it says, where is it? Completed. There's a date and time. And I edited this because I didn't want you to see which students this was, but you know, take a picture, do a screenshot of the whole page so I can see your name at the top too. And then you email me this. Do not, now I'm recording this, so do not email me any answers to any questions on that evaluation. That is anonymous. I just need this little page showing me you did it. That's all I need, so I can give you participation credit for it. That's all, just take a screenshot of that. All right, I'll remind you again on Thursday and Tuesday of next week. But there's that part of it. So this is an easy part. This is definitely gonna get a 1 out of 1. There we go. So this person's participation grade is a 95.3, and notice it automatically shows up right there, but I've got to move this 5% over once I have that in there. Now it's affecting the grade. Oh, that's because you gotta have grades for everything. Hang on. All right. I know we're wasting time, darn it. Hang on. What's this person gonna have? Hang on. 100, 100. We got too many of these to go through, so I'm gonna go fast. Where's the first quiz? There we go. Let's say they fell apart. How bad?
79.
Oh, wow, I was 68. Hang on. Okay, 72. We'll compromise. All right, we're back on track with the homework. Are we still there? All right, hang on. I don't know, we fell apart on homework. These are zeros because we didn't have it in class. We didn't have it homework, right? We have this homework. Let's see. Anybody watch that Michigan Ohio State team?
Great game.
Oh my gosh. Oh, I wish I was there. I would have rushed that field. That looked so fun. I've never been on that field. I've been to probably 1,000 Michigan games, and I've never been on the field.
Every time I go, we lose.
Don't go.
That's like a record right now. They're defeated every time I go.
That's awful. No, yeah, I'm never asking you.
No, I didn't.
Okay, quiz 2, did they blow it again? Let's say they blew it, 70. And that one's worth 15%. Right, more homework. Always get it together right after a quiz, because we're so shocked we did so poorly. Here we go, 11 homework in class. Okay, so quiz 3, how'd we do? We blew that one too? 71. All right, and now we have, what is this, chapter 12 in class? Or week 12, excuse me. That's it. Now we have grades for everything. Everything that's great. So this person, even though they got a 71, a 72, and a, what was the other one? 72, a 70, and a 71, still has what grade in this class? If you were to look on the main syllabus, what letter grade would this person have with that total right there?
B.
B. Because the B goes all the way down to 83, not 84 like traditional, all the way to 83. Just like the A goes all the way down to 93, and the C goes all the way down to 73. What do you have to have in this class, not number-wise, grade-wise, to go on to DS 302?
C.
A C. Number-wise, what does that bottom right-hand corner have to be at or above to go on to 302?
82.5.
Good. Well, that's all over it, man. 82.5. not 82.49, 82.5, only go one digit to the right to round. So you gotta have that 0.5. Is there anybody not going to DS 302? I was just asking, just checking. Is there anybody gonna try not to go? That's what I wanna know. Is there anybody trying not to go? Thank you, Colin. Thank you for volunteering for that. I
From
appreciate
what I
it.
heard, it's not fun.
302 is not fun, but you gotta have it to get to the end.
Yeah.
Yeah, I suggest taking it sometime.
Why don't you take it?
I took it
Why don't you
already.
teach it?
I took it when I was your age.
Why don't you teach it?
I'm sorry?
Why don't you teach it?
I have, but because I only teach 2 classes, they need me to teach this. But I have taught that 302, God, it was only like 2 years ago, 3 years ago I taught it.
We can create a petition, don't worry.
I appreciate that, thanks. That's never gonna happen. And you guys realize I only have 3 semesters left after this, right?
Same here, we'll leave together.
We'll walk out together.
What other class do you teach?
This is, I've taught 26 different courses. By the way, I had some conversations at a faculty meeting recently. I didn't realize that was such a big deal. The other faculty members said they've never met anybody who's taught 26 different courses, and that the persons, everyone at the table, the highest was a 10. That they've taught 10 different courses, but I've taught 26 different courses. So I guess that's a big deal. But they're all numbers oriented, so I found them all very easy to teach, because I was always a numbers person, so I don't know. But finance, accounting, and anything else has to do with numbers. My forte though is a class called management science, if anybody's gonna be taking that. I don't think it's a required class for a degree here. In Flint though, it is a required class. And it's about using mathematical models to make business decisions. And it's a very useful class for management. We gotta get into the new stuff. We're wasting so much time, but it's been fun, because we're at the end of this semester. Uh-oh, that's if we have time at the end. Here's the homework assignment for this week. This one's the last one that has to be handed in a week from today. And it's gonna be, you're calculating, determining the upper and lower control limits on all these, I think. Number 1, upper control limit. Number 2 is just like number 1, but you gotta use Excel to find the upper and lower control limit. By the way, UCL stands for upper control limit, LCL stands for lower control limit. Number 3 is also manually calculating the upper and lower control limit. Number 4 is manually calculating the upper and lower control limit. And then number 5 is again using Excel. The Excel command we're gonna learn on Thursday is called confidence, using it to find the upper and lower control limit. So there's the homework. It's only 5 problems for your last homework assignment. I will create a week 14 homework assignment, but I'm just gonna post it for maybe a day or 2 and then post the answers right away so you have it to study, to prepare. Don't forget that week 14 homework assignment, the one from next week, will not be part of the first part of the exam. It will be part of the second part of the exam. But this homework assignment that you're looking at that's due Tuesday, this could be on the first part of the exam, just like the one you just handed in could be on the first part of the exam. All right, so don't forget, the first part of the exam is a week from this Thursday. The second part's on the final exam day, the Tuesday after that. Now, let's get into the good stuff. Let me think here. We talked about, I want to make sure we looked at the spreadsheet, we talked about the evaluation. Everybody knows how to take a screenshot of that, right? All right, let's do it then. Let's get into statistical quality control. This is an important subject. Not only is it preparing you for operations management, I know they're doing quality control and operations management, but also in DS 302, I believe there's a week of quality control in the next statistics class also. So I'm just getting you just the basic, hey, how do you find the upper and lower control limit? How is this used in business? Why is it used? And I happen to be old enough to have seen how remarkable manufacturing has been able to change because of quality control. In the old days, I remember being a real small kid and my parents bringing home a car. And my father worked for General Motors my whole childhood. And so when we would get a new car, it'd be like so exciting. My sisters and I would jump out, get in the back seat, you know, oh my God, we got a new car, this is so great. Come on, Dad, take us for a ride. That car would be rusted out within 3 to 4 years. Completely rusted out, having to get fixed. Cars almost never made it to 100,000 miles. I mean, cars didn't last that long. They were just turned into junk after a short time. And now, what a difference. I know so many people that are driving cars that are over 200,000 miles, that are over 10, 12, 15 years. I've seen cars out there over 20 years old. I mean, not taking care of special, just regular cars, making it past 20 years old. Does anybody happen to have a car that's up around 200,000 mileage? Nobody? What are you guys all rich? What's going on? Ali, that Cadillac does not have.
No, I got another car at home. It's like a Trailblazer, like 06.
Oh, okay.
You got like 208,000.
And it runs.
Yeah, but like nobody drives it.
Listen, 06, look how old that is. That would never happen before quality control. Never. If there's one industry that quality control revolutionized, it's the auto industry, in Detroit in particular. And Detroit was the leader in using quality control. You know, I can remember working on my master's degree and I was studying case studies from companies in Detroit who revolutionized quality control. It changed manufacturing so much. So here's the deal. Sometimes you're out there driving around, you guys, we're all in Southeast Michigan, so there's a ton of manufacturers because there's a ton of suppliers for the auto industry. You've heard of tier 1, tier 2, tier 3 suppliers. Well, I used to work for a tier 1 supplier for Ford. I was the corporate controller for Ford Planning and Management. And quality control is such a big deal that the suppliers go after a certification to prove that they're quality control compliant. And it's called ISO 9001 certified. Sometimes you'll be driving down the highway and you'll see on the side of a building they'll have a big banner that says ISO 9001 certified, because that's a big deal for the company. To get that certification means they can supply for you. Meaning a big manufacturer will go ahead and subcontract them as a supplier because they have that certification, which means that they are doing quality control practices and making quality control parts. That's the big deal. Okay, so now let's talk about this. How does this work? I'm going to use just little ball bearings as an example. This company supplies for the auto industry, and they're making these ball bearings. Just quick, the machine's just whipping them out, taking this raw metal, shapes it down to a ball bearing to the perfect diameter, and whips it out. All right. In the old days, they do like 10,000 of them. That would be a batch. It's called a batch, however many you run the machine for. And they would call whoever they're supplying these ball bearings for and say, hey, we got a batch ready, 10,000. They would come pick it up. Usually the manufacturer would come pick it up, or they'd say, are you ready for us to ship it over? And before quality control, those ball bearings would get shipped. They then get manufactured into the cars, and some of them are the wrong size, and some of them have these holes in them, and some are defective, and no one knows what's going on, and these cars, this is why they didn't last. So now, the manufacturers started saying, hey, we need to start inspecting these items we're making during the process of manufacturing. So, during the process of manufacturing, that's called detection inspection, detection quality control. It's usually done by the manufacturer during the production process. So we're making the ball bearings, and a lot of companies will do it like every 2 hours or every 3 hours, or even, depending on how important it is, maybe every half hour even. And let's say this machine's making 1,000 an hour. An hour goes by, they take that batch, they'll put it off to the side, let the machine still run, and now the quality control person, which could be you, this is a great, by the way, this is a great entry-level job into a manufacturing business. When you are going into quality control as a way to get to management, you know, you're kind of looked at as being special because you're doing something that a lot of people don't know how to do. So if you find this interesting at all, this would be a great path to get into management through quality control. By the way, it's a real quick way to start making 100,000 only like 4 or 5 years out of college, if you really get this. So, the quality control inspection, go ahead, Alan, I'm sorry.
They make it the first year out of college.
So, I can't help myself. Are we recording this? Okay. The inspection, the quality control person who works for the company will randomly now select the ball bearings. There's a laptop over here. There's a USB thing there, and this machine, the ball bearings get put into it, and it's measuring it down to, you know, millimeters in diameter. Measuring it down to millimeters, and whatever company you work at, they have traditionally how many they're going to do. And let's say this inspector does 30 of them. has it calculate the mean diameter for those 30. There we go. Now, they get put off to the side. They don't get, sometimes it's replacement, sometimes it's not replacement. Remember that from a couple weeks ago. Randomly selection with replacement, random selection without replacement. Let's say this one's without. Picks out 30 more, puts them in the machine. It finds the mean diameter for that one. It does this, and a lot of companies will do this process like 6, 7, or 8 times. It will look at all 8 of them, and then it will look to see if the mean diameter is within the upper and lower control limit. Everybody hear that? That's what we're going to learn how to calculate. If all 6 of them, or 7 of them, are within that upper and lower control limit, they know that that batch is going to be good, and now they put those 1,000 ball bearings off to the side until they get to 10,000. Now another 1,000, another hour went by. They do it again. That's that person's job right there every hour, is to do that quality control test. Here's what happens now. We call Ford. Hey, we got a batch ready, 10,000, ready to go. Send your quality control person over. Ford then will send over an acceptance inspector, quality control inspector. That person comes over. This is after the production process. And they're gonna do the same thing that that company did. They use their own laptop, they have their own machine hooked in, and now that person's doing the same thing because all those 10,000 are there ready for shipping, and they're picking out a random 30, put it in the machine, and doing the same thing the person did before. But now they've got all 10,000. So they may do that 10 times or 20 times. They will look at the mean diameter of all of those and look and see if they're in between the upper and lower control limit. If all 20 of those are in between the upper and lower control limit, they sign off on it, and that means that company's now going to get paid, and those can now be shipped, and those are ready to be put into the manufacturing process at whoever they're supplying for. That's how it works. I've witnessed it. It's not that bad. By the way, let's take a look. I did a quick search. Whoop, where is it? Here we go. I just went to Indeed and put quality control, and I found these two. This is a quality control technician second shift, $20 to $22 an hour. And then this one is quality auditor, $24 an hour. I opened that one up, wanted to see. I was looking to see if you had to have your bachelor's degree. This one's in Canton, Michigan, $24 an hour, 8-hour shift, plus you could get some overtime. It's a day shift, Monday through Friday, you get weekends off, it's full time. You're in an office. What else do I have? Look at all the benefits. You get retirement, matching. We talked about matching, didn't we? What's the rule? What should you always do with matching?
Max out.
You should always get the max matching you can get. That's free money that you don't want to pass up.
This is an out of college job?
That's what I'm trying to figure out. I was going down saying, okay, do you have to have a bachelor's for this? But it doesn't say you have to have a bachelor's. You just have to have some education and knowledge. And a lot of them are beneficial. It doesn't mean you have to have it, but it make you a better candidate. What you do have to have is Excel, Word, and PowerPoint experience, which you guys all have, all right? Good, excellent verbal, written, and communication skills. Okay, you guys don't all have it. What? I'm just kidding. You all have it. Experience in a warehouse or manufacturing setting. Beneficial to have that Sigma experience or certification. That you'll learn that in operations, what that is. That's quality control inspection also. That's what that's called. That's a different certification you can go for as an individual. That shows that you know how to do quality control. It doesn't say, and then you go down here to nothing about what your education. I didn't see a bachelor's degree on here at all. But then, let's say you work this job for a couple of years and you want to make more money. You go up here, let me go right here. Senior quality technician, 32 to 38 hours. $32 to $38 an hour. And then I scrolled up a little more. Quality control engineer in Troy, $70,000 to $80,000 a year. I mean, you just keep going up to the next one. And by the 5th, 6th, 7th year, you'd be at 100,000. Once you've got past this one. Anyway. So it's a great entry-level job, something to think about. So now, where was I? We did the detection during the production process. We did the acceptance inspection at the completion. This detection is usually done by the seller. The acceptance is usually done by the buyer. They're the ones then who will sign off on it, so we know it's gonna happen. I wanna give you an example. If you got your book, I'm on page 261 from your book. Here's a perfect example. This company makes milk, produces milk for the grocery store, let's say. And they now have a machine putting it in 1 gallon jugs. So the milk's going into the 1 gallon jugs, and every 2 hours, the company samples 25 jugs to calculate the following. Now, it says, assume when the machine's operating properly that the amount of milk that should be in the jug is 128 ounces. So that's what the goal is. By the way, that goal, that mean, when you're going to inspect it, whatever it should be is called your center line. Your center line, your base, your center line. That's whatever it should be. Your upper and lower control limits are based on that center line. So when we try to figure out what the upper and lower control limits are on this milk machine that puts the milk in the jugs, we're going to use 128 as our center line. Then it says it has a standard deviation of 2 ounces. There you go, there's the standard deviation. Here's the formula to find the upper and lower control limit. Whatever that center line is, you're going to add and subtract. By the way, this adding and subtracting are the last steps. You're doing both. You calculate all this on the right, then you add it to the center line, then you subtract it from the center line. 3 means we're going to use 3 standard errors above and below the center line. 3 standard errors. Most companies use 3 standard errors, but some are using 2.5, 2. It all depends on the importance of that particular item that they're being manufactured. Now, we're only talking about this right now, the standard error of the mean, because this problem's about a mean. On Thursday, we're going to use standard error of the proportion, like we did in the homework, but this one's just about standard error of the mean. Standard deviation divided by, excuse me, the square root of the sample size. That is what's done first. Standard deviation divided by the square root of the sample size. Take that result, multiply it times 3, then add it to the center line, then subtract it from the center line. That's how you find your upper and lower control limit if a mean and standard deviation is part of the problem, which it is in this one. So help me with this one. What did I say the center line was? Anybody? For this milk, we're filling the jugs up to how many ounces?
128.
128 plus minus, plus and minus 3 times. As said in the problem, the standard deviation of this machine when it's operating properly is what? 2 ounces over the square root. Now here's the deal. There's the results from 6 tests. 128.7, 128.4, 128, 127.8, 127.5, 126.9. We did this 6 times, but the problem says every time we ran this inspection, even though we did it 6 times, we used a sample size of 25 jugs of milk. That's what goes into the sample size. However many were used each time the inspection was done, that's the sample size you use. Not because we did this 6 times. We're not going to use the square root of 6. We're using the square root of 25. Square root of 25 is 5. 2 divided by 5 is 0.4, I think. 3 times 0.4 is probably 1.2, I'm guessing. That's all the guess. So 128 plus 1.2 equals 129.2, if I'm correct on 1.2. 128 minus 1.2 is 126.8, I think. Let's see. Hang on, the answer's right here. Oh, I'm off, right? No, I got it. 129.2, 126.8. There's our upper and lower control limit. Who's going to jump in right now? Who's going to tell me? You are the quality control person at this milk company. You just ran all 6 of these 25 at a time jugs. You hooked the machine up. You've been pouring the milk in this machine that's hooked to this laptop that measures it down to the 1/10 of an ounce. And here's your results after doing 25, then did another 25, another 25. My question is, do we need to stop the production process and adjust this machine because it's out of whack, or is everything running good? Why? Why?
So between the upper and.
Everybody hear that? Every one of these numbers are between the upper and lower control limit. Thank you, Eva. Every one of them. And because they're between the upper and lower control limit, there's nothing we need to do. They pass inspection. We're gonna wait another couple hours, or what do they say, every 2 hours? I think it says every 2 hours they do this. We're gonna go another 2 hours and inspect again. That's how it's done, exactly. You see how easy it was to calculate the upper and lower limit. What I wanna prepare you for the exam is, I don't want you just to be able to calculate the upper and lower control limit. I want you to be able to answer the question of whether the machine needs to be adjusted or not. I need you to be able to answer that. Should we stop production? Because the moment any of those fall outside the upper lower control limit, you gotta stop production and get it stopped and make the fine adjustments you need to make. I used to work for this company, a consulting firm, and I was traveling all over the eastern part of the United States, working with companies. Each week I was working with a new company, And my job was to look at all their financials and to go through their processes and to figure out why they're not maximizing profit. In some cases, even losing money. That's why they'd call me in sometimes. So, with that being said is, a lot of times, companies they'd have like a warehouse this big, and they'd have a machine over in that corner making something, and a machine over in that corner making something, and a machine over here making something. And they kept having these problems of having to make adjustments because the machines were falling out of the control limits. And what was going on was, there was so much vibration from the machine in that corner on the cement of this warehouse that it was causing the other machines to go out of whack after a certain amount of time to go by. The vibration did it. This happens to be called random chance variation. Vibrations, misreading instruments. The most common vibrations that I experience. Human error is another one, but most errors are human. But vibration from having multiple machines on the same floor, too close to each other maybe, causing that machine to kind of go out of whack. Let's say the manufacturer of the raw material we bought has slight defects in it, and we didn't notice it. And it's causing, but we're using the material that has these slight defects in the manufacturing process. But then they're getting caught when we're doing our inspection, quality control, after it's been manufactured. Meaning we have money into this now. That's called an assignable variation. An assignable variation, it's a correctable event. That this was a one-time thing. Or let's say someone on a forklift ran the machine and didn't report it. And all of a sudden the machine's spitting out some bad quality items and we're going, stop production, something went on. That is called an assignable variation. It's something that can be corrected. It was an accident. So what I need you to know about this is, what's the difference between a chance variation that we caught that could cause the manufacturing process to go off and produce bad quality, or an assignable variation? What's the difference between them? One is random events, one is a correctable event. It wasn't so random, a human caused it most likely. All right, so where are we at now? Let's go to control chart. Wait, let's see what this has to say about it. Here we go, acceptance sampling used at the completion of a production process. Detection sampling, inspection occurs during the production process, not after, during, in order to detect any non-conformances to specification. The detection approach came after the acceptance approach because manufacturers started realizing, let me make sure you understand, this is a big deal. A supplier for the auto industry, if they had an order refused because of quality, they had to take it back. They had to spend the time to pull out all the defective items, remake all the ones they pulled out and replace them, and then re-deliver the order. Manufacturers, suppliers were finding that so expensive that that's where detection inspections started to become big, because the suppliers started saying, let's spend the money and hire our own quality control and start doing it during the production process so that we can ensure that we never have to go through that again. That we know for sure that Ford, General Motors, or whoever is gonna accept the load, the package that we're shipping, because we quality control inspected it, and we know that they're gonna pass quality control when it gets there, or when they send their person over to inspect it. That was the key. That changed everything when the suppliers started saying, we're willing to spend the money to have our own in-house quality control, doing it during the manufacturing process, because it will be, they realized it's less expensive than to go through what they had to go through to replace a whole order that didn't make it past inspection and they weren't gonna get paid for it. All right, chance variation, I'm on slide 60, caused by a number of randomly occurring events that are part of a production process. They're not controllable by individual worker or machine. You know, as long as we want to keep these other machines going, they're going to keep vibrating, so we just got to keep dealing with it and keep making the adjustments on the machine that's affecting it. Assignable variation caused by special events or factors that can usually be identified and eliminated or identified and corrected. Okay, now we're getting to the good part. Control charts. Here we are. Let me go back to this. I want you to see a control chart. We're going to use the melt control chart. We calculated the lower control limit at 129. The upper at 129.2, the lower at 126.8. We make a control chart. There's 3 lines on the control chart. Looks like this. The middle line is always your what's it called again? Center line. Your base, your center line. So the 128 ounces would be that center line. The line at top will be your upper control limit, which in this case is 129.2 ounces. Your line on the bottom, again, I don't know these colors because I'm colorblind, but is that blue? I can see blue, but what's this middle one?
Green.
Yellow?
Green.
Green? What's the top one? Red?
Red.
Yeah, that was tough. Red and green are my worst colors. Blue is going to be at the lower control limit at 126.8. Now I want you to see all of those inspections of that melt landed between the upper and lower control limit, but look at this last one. This is so close to being below that lower control limit. If this were real life, now look, if this is on the final exam, your answer is the machine does not need to be adjusted. All right, let's stay with that. But in real life, this is obviously starting to head out of control here. That to have one so close to that lower limit and to ever have a straight line like that, because control charts are almost always, again, they're almost always like this. Like that, like up and down and over. A straight line like that tells you there might be something going on. That if this machine doesn't need adjusting because they're all within the control limits, you can almost predict that there's going to possibly be an adjustment needed. Because it's looking like it's going to fall below that lower limit. Okay?
Got me. Handicapped.
Ooh, I'm in handicap. Sorry, guys.
I don't know if that means you get the ticket or what, but, where was I going with this? So there's what a control chart looks like, right there. I'm gonna show you another control chart. Oh, no, I'm not. There's one right here. Oh, no. Right there. Okay, look at this control chart right here. Does the machine need to be readjusted, or is everything fine? We can continue production. Look at that control chart. Come on, who's with me? Does the machine need to be adjusted, or can we keep manufacturing? Everything's fine. Adjusted. Why? Look at how it went above the upper control limit. That's how you read these control charts. All right. Whoa. Let's go back here. There's your control chart. Plot the calculated statistics for a production process over time. You're looking to see if it goes above or below the upper control limit. Center line, the mean when the process is under control, the expected. That milk jug, we want it to be 128 ounces. That's our goal. That's why that's the center line. Upper control limit is 3 times the standard error and being added, and 3 times the standard error being subtracted from that center line to get your upper and lower control limit. And there's that control chart again for the melt right there. All right. The only other thing I want to mention here, here's another thing I forgot right here. Hang on. All right. You remember this?
I do remember this.
This is the 5 keys to career happiness. When you're looking at a career, and you're evaluating whether you should leave that career to go for another career or possibly stay at a career, these are the 5 things you want to look for, especially when you get into management. This is the key. I'm telling you, you want to try to create these 5 things within the career you're at whatever company you're at. People you work with. You want to make sure you're working with people, or you want to do the best you can to get along with people you work with, because you end up spending more time, especially first out of college. You're not working 40 hours a week. If you really want to prove yourself at that company, you're putting in 50 hours a week at least. I remember one of the companies I was at when I first got into management, I was the assistant director of admissions at a college. Anybody in management knew you had to show up on Saturday because all the top managers show up on Saturday, and so you had to show up Saturday. You had to make sure they saw you, that you showed up on Saturday if you wanted to get into top management. So that, plan on it. You end up spending more time with the people you work with than your own family when you're in the beginning of a career. So that's a key, that you're working with good people, that you enjoy working with them. You can have fun a little bit on the job, so you don't hate it. Next, people you work for, that you respect the person, your direct supervisor, that you feel that people you work for are knowledgeable about the company and the direction it's heading in. Once you lose respect for the people you work for, you end up hating your job. If you end up knowing more than your direct supervisor at how to do the job, you end up hating your job. So it's the people you work with, the people you work for, those are 2 of them. Next, fair pay. That you feel you're getting paid fair for the particular responsibilities you have. That it's a fair pay for the particular responsibilities you have. Challenge. There's nothing worse than getting bored on a job. But this happens to be one that's really in your hands. The people who end up not feeling challenged in a job are the ones who don't do anything about it. The easiest way to start feeling challenged about a job is to ask for an additional responsibility. Just ask for it. Believe me, you will bring it up again when it comes to the yearly annual review, because that's what determines how much your pay is going to be raised. And at that annual review, if you get to talk about that you requested additional responsibility so you could feel challenged in your job, that's going to be a big deal. That happens to be the one that usually got me the biggest raise of everybody in my department, is because I was the one asking for additional challenges, for additional responsibilities. I never asked for additional pay because I knew nobody gets additional pay until they get to that yearly review. But this is a big thing to talk about during the yearly review. Plus, then it stops the boredom at the job. When I get to a job, I end up picking up on it really fast. So you go from a job that takes you 40 hours to now it's only taking you like 28 hours because you just picked up on it so fast. Don't just play freestyle or minesweeper during the other hours. Instead, ask for additional responsibilities. Take on a challenge. Because if you get bored, you're going to start hating your job. I bring that up because I was the king of minesweeper. Because I did. Even when I took on additional responsibilities, I still had free time. Opportunity. You have to see a load of opportunity where you work. Everybody has a little bit of part of them who wants to move up at whatever company you're at, and you have to be able to see the load of opportunity. If you happen to be at a job that you see there's no way you'll ever get into management, or no way ever get to where you can make more money, or even get different kind of responsibilities, then you need to look for a different job at a different company or a different department at the company you're at, because road of opportunity is a key to part of the happiness in a career, that you see a road of opportunity to the next level, whatever that may be that you want to accomplish. Believe me, after you've been at a job for a few years, you start wanting that next level. It's just a natural reaction. And so if you got to see that is possible in the position you're in, that there is a next level you can get to. So those are the 5 keys. That's it. Opportunity, you feel challenged, fair pay, people you work for, and people you work with. That's the key to happiness in a career. That's it. How'd we do? We're okay. We're on time. We have an in-class on Thursday, your second to last in-class assignment. And that's it. I'll see you on Thursday.